Hey there, everybody. Welcome back. Shit, where's Lauren? There we are.
I'm here. I think
There we
we're on 23, I think.
Okay, good. Feeling any better?
Not really.
That's well, I hope you feel better soon. Day 23. Today we are covering 14.1, which is on polynomial functions. And we're going to start 14.2. I'm going to say 14.2a, because I don't think we'll finish it. Rational and irrational roots of polynomial functions. And something you are going to need to know how to do and know how to do well is related to polynomial division. It's called synthetic division. This is a shortcut for doing polynomial division. So let me just pick a nice little simple problem to go off of. Let's go with x cubed minus 4x squared minus 9x plus 36 divided by x plus 3. This is polynomial division. So maybe I should start off with saying what polynomials are. Polynomial, I'm going to have to say this again in the next class, but a polynomial is, it's an f of x in the form an x to the n plus an minus 1 x to the n minus 1 plus dot 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 a1x plus a0. AI, where I goes from 0 to n, these are all real numbers. And preferably integers for a lot of the stuff we do. But we can never force it to be an integer unless the situations are right. Oh, and the zero, the n term, the exponents. There we go. Exponents are integers, are positive integers, or non-negative integers.
What does the subscript mean in this situation?
So like these are all A's are all coefficients. And the I represent which one it is, and it's related to the power. So it matches the power. We tend to label the subscripts so they match the exponent.
Oh, but it's not that like it's,
It doesn't affect the value there whatsoever, like this is A3. The one in front of this is A3, -4 is A2. So that's actually worth pointing out to help clear confusion.
it's not like log of one or something.
No, so like A3 here is 1, A2 here is -4, A1 here is -9. And A0 is 36. And the reason why I say non-negative integers, this is like greater than or equal to 0. Because the A0 term is literally like x to the 0. So we do have a 0 exponent present.
But A1 in that situation is not me plugging 3 as x. That's not
No,
what that, so, okay,
no, these are just, the A's just represent the coefficients. So the AIs are just coefficients. For the x to the ith power terms. Otherwise, we gotta go like A, B, C, D, E, and like, we never know how far down the road we're going. And like, for different polynomials, if we're just doing like starting with A and going through the letters, sometimes the constant would be F and sometimes the constant would be C. So rather than just having things that change, to keep it consistent, we can always say this, use a subscript and line it up, and so this expression never changes. Because like when we did our quadratics, we said ax squared plus bx plus c. We had a cubic, now all of a sudden I gotta go ax cubed. And now the a is on x cubed, not x squared. That's not good. That can get confusing really quickly to new students or new to something. So we're gonna use like an a set with a subscript. Does that make sense to everybody? It's not really important in long term. This is, we're not gonna use it in calculations or anything like that. It's just to help make it clear like what the hell this is saying. All right, so we could do, and we're not going to, polynomial division. Actually, maybe we should, and then we'll show you synthetic division on the same problem. So, to do division, we are going to write our function that we're dividing. And we're gonna do that whole good old, like this works identical. It is identical in process to doing regular long division with numbers. What we divide by is, what I'm gonna do is I'm gonna take this x plus 3 and we're gonna set it equal to 0. And we get x equals -3. This will, we're not doing that here. This is what we'll do in synthetic division. What we're doing here, we're just gonna use the x plus 2. I got ahead of myself.
so with what we know right now, with what we already know, we could have done this by splitting that function in half, and then we could reduce the top bar. We could reduce the top side of the fraction that x.
If you could factor the top bar,
If we can factor.
then you would be able to do this. In fact, that's what you're gonna learn how to do today.
This is a faster way of factor.
You're gonna learn how to factor any polynomial. Holy shit, x to the 5th polynomials. What? We've capped out at best with x cubed, and only when we had a cubed minus b cubed. That's the best we've done so far. Now, sky's the limit after today. Well, maybe after Tuesday, because we're not gonna finish 14.2 today. I don't think we will, but we might. So what we do is, like, let's picture what you would do if we were dividing 9 into 128. You would go, does the 9 go into the 1? No. Bring the 1 down, carry the 12 down. Does 9 go into 12? Yes, it goes in 1 time. What we did at this point is we took, let's do this instead. Let's do this following along, going along with what's up here. So we're gonna do the big things. Does X go into X cubed?
Yeah.
It does. What do I have if I divide?
X squared.
We have X squared. So that's what we put up top. That's just like doing the 1 right here. Now, what we did in long division regularly is take this 1, multiply it by the 9. And subtract it, minus 9. And we would get 3. And then we would bring down the 8. Go to a long division, right?
Yes.
All right, so we're gonna do the same thing here. I'm gonna take this X squared, and I'm gonna multiply it times X plus 3, the whole thing out front. And I get X cubed plus 3X squared. And like we did down here, we subtract it. Identical procedure.
But here we have to, I guess identical in a sense, but it would be a negative 3x squared.
Yeah, I gotta distribute the negative.
Distribute it.
So I gotta distribute, so this will be a negative and this will be a negative.
Negative 7.
So when I subtract, I should get 0x cubed. That's by design. And I have -4 and -3 is -7x squared. And I bring down the next term to -9x. In fact, with that being a 0, I don't need to write it. I'm just gonna like cross it out. And then here, what do we do down here? Rinse and repeat, right? Same procedure. 9 goes into 38 4 times. 4 times 9 is 36. We subtract the 36, we have a 2. So where this goes up here, we're doing X now into -7x squared. Let me change colors here. So -7x squared divided by X is -7x. And then I'm gonna take the -7x and multiply it by the X plus 3. And I have -7x squared minus 21x. And then we're gonna subtract that. I strongly recommend, if you do the long division, putting it in parentheses, that way you remember to distribute the negative. When you distribute the negative, that becomes a positive, that becomes a positive. -9 plus 21 is -12 or positive 12.
Yes.
So I have 12x plus 36. Bringing down to 36. And we'll do our final form of long division. 12x divided by the x here is just 12. It's a positive 12, so I'm gonna say plus 12.
What about the remainder in this situation?
I'm getting that.
Okay.
It's a good question. I'm glad you're thinking about it. Because this one has a remainder. This one's not going to, but what do we do if we have a remainder? I'll show you. So we do our multiplying. 12 times x is 12x. 12 times 3 is 36. I subtract and I get 0. This would be the remainder. So. Down here, I could write 128 divided by 9 equals 14 remainder 2. But generally, we don't say remainder 2. We write it in terms of this divisor out here. We would say 14 and 2/9. So the remainder is here, and we put it over that bad boy. And this is the same thing as 14 plus 2/9. What we do here, x cubed minus 4x squared minus 9x plus 36 over x plus 3 equals, when we do the division, we have our numerator. And then if we have a remainder, plus the remainder over what's out front. But r equals 0 here.
Do we factor out the remainder, or is it done?
No, well, this is the division, and we're not done factoring if we wanted to keep factoring. In fact, let's do that. But that's how polynomial division works. So what that means. Another way of looking at this, we have that x cubed minus 4x squared minus 9x plus 36 over x plus 3 equals x squared minus 7x plus 12. The remainder is 0. I'm not going to write 0 over fraction because that's a 0. What happens if I clear fractions?
You have to
What happens to the x plus 3 on the left side?
distribute it throughout the other both sides of the equation.
I'm going to multiply by x plus 3 on both sides. I am not going to distribute.
Yep.
This is going to equal, I'm going to put the x plus 3 first. And then x squared minus 7x plus 12. This is it's the factoring. We have started factoring a cubic. So if I want to factor it further, does this factor?
It's x minus 3.
That's x minus 3 and x minus 4, right? So this would be x plus 3. And here we have x minus 3 and x minus 4. And that is a full factoring of x cubed minus 4x squared minus 9x plus 36.
Also means that x squared minus 9 is here. Makes sense.
X squared, we could do, I could have divided this by x squared minus 9. Well, in this case, I gave us the x plus 3. I knew this was going to factor. If we're starting with the x cubed, though, you may not know where to go with this. This actually, we could do grouping, and it's noticeable grouping. Group the first two together and pull out an x squared. Do the second two together, pull out the -9, and we have that x squared minus 9 you're talking about. But like for higher terms, it's not, the grouping isn't something you spot. We're going to have a process for identifying what possible factors, what possible numbers here can go at the end of these parentheses. That's going to be the second half of our lecture today. But synthetic division, this took a lot of room. You don't want to do this. This is a full page event, right? So synthetic division, what is synthetic division? I'm going to put my x cubed and I'm going to put the whole thing up again that we started with.
And so you could use polynomial division if you had like x to the 8 and like a huge problem.
Yes.
You could use it. But
And if you're lucky, you'll get enough answers. You'll see, not every answer is a rational answer.
yeah.
You can get irrational numbers for answers quite easily. Like if x squared minus 2 is a factor, now you've got plus or minus the square root of 2, and the methods we have won't help you find it yet. You'll learn about methods to find it in like calculus. But if we can make a fraction out of the answer, including this like something over 1 is a fraction. If we can make a fraction out of the term, we can find it with today's method. As long as it doesn't have no square roots or like imaginary, like it's gotta be just a fraction. Okay, so synthetic division works like this. We take this and we set it equal to 0 and we find out what x equals. Here, take the coefficients and make a chart. I'll show you. Make a table, I'm gonna say. And I wanna say if an x to the I term is missing. It has a coefficient of 0. So you'll use 0, and I'll show you an example of that in a second. This one doesn't have any missing gaps. So polynomial division is the long way, but it works and it's based off long division. So what I'm gonna do is my table, rather than doing our bar that looks like this sumbitch is gonna be flipped upside down. And I'm gonna put the coefficients up here. So these are my coefficients, they go in the top row. My x equals -3 goes out here.
So this comes up again a lot in calculus, right? Or, I feel like I've seen this.
You might have seen it before. It's the fast way of doing polynomial division. We are gonna get the same answer that we got a little bit ago without doing that long form. So the way it works is you bring down the first term. And then I'm gonna go -3 times 1, this times that. I'm gonna put it right here. The result of that multiplication.
-7.
And then we add them up and we get -7. And then I'm gonna do it again, -3 times -7 is 21, and I'm gonna put that here. I add these up, I get 12. -3 times 12 is -36. I put that here. I add this up and I get 0.
Yeah,
Does this look familiar to anything we did over here?
yeah, that was a lot easier, smoother.
Notice if I put a coefficient there, 1 -7, oh shit, that got bright.
I was like, whoa.
I'm going the wrong way. Let there be light. 1 -7, 12. 1 -7, 12. Remainder of 0. R. So this bottom row, after doing this process, is the coefficients. Coefficients. God, this doesn't look right. Coefficients of a polynomial 1 degree smaller. So this was x cubed. X cubed drops down to x squared. And I have x squared, I have an x, And these just get strip mined and put there.
You just subtract everything on top, correct?
What do you mean subtract? I added,
No, I meant for the x of like x cubed, now it's going down one, so it's x squared.
yeah, all the term powers go down by 1. And then I have a remainder of 0. This would be 0 over x plus 3, but that's just 0.
So degree the as well.
Yeah, I guess I haven't talked about degree of a polynomial. Degree of a polynomial is the highest exponent.
Oh, it's in the motion sensor.
I'm off the screen. So if I eliminated the text that I wrote, if I eliminate this text and I eliminate this text, look at how little room synthetic division took as opposed to polynomial division. In fact, I'm writing it kind of big just to make sure it's visible well. If I were a student using pencil and paper, I could make this a really fucking small thing on my page.
But they're both good, useful tools to
Well, they both do the same thing. This is just a faster way of doing the long one. It's literally the exact same steps. Rather than subtracting, we subtracted over there, here we add, but here we solve. So we changed the sign of this +3.
Yeah,
And so it compensates for that subtraction.
is x equals -3 the derivative?
No.
No.
It is called a root or a solution. If I set this equal to 0, it's one of the solutions. Derivative for a function is in calculus, it's the slope of the line at the tangent line at that point.
So
Here, that's
nothing.
yeah, don't bring that up. You're just gonna drive down. I could show you later how to do it, but if we talk about it in here, everybody's gonna just be like,
we're just setting points right
Yeah.
here.
right. Does this seem doable? You guys wanna try your hand at one?
Yes.
I wanna make sure I don't use what I'm gonna do in a little bit. Okay. And another way of saying this is -2 is a root or solution. You'll see it like this in problems. This means x equals -2 is an answer. This is the same thing as x plus 2 equals 0. So I'm kind of asking you to divide this by x plus 2 right now.
So so we might see something that says -2 is a root. And
Yeah.
be like, what can we do about that?
Yeah. But that's where we're going with it. We're going with it really quickly today.
Wait, are we? Oh, okay.
So like if we see, hey, did you know this is a solution to this problem? That's what it means. It means x plus a variable plus that number equals.
Yes,
Alright. Because it's a solution, it's one of these solutions.
yes,
From that solution, we can actually bring down the problem and begin taking the main problem apart on the other solutions.
right. Where we're going with this is then we're gonna learn how to graph. Because this will give us where it crosses the y-axis or the x-axis.
And so we don't need, I've been wondering what the what like the quadratic formula would be for x cubed. Like in the other versions, like. You put it-
There is a formula for a cubic, there's a cubic formula. It's ugly as fuck. I don't know it. It's too difficult to memorize.
But you could just do this and break
Oh,
it
yeah.
all the way down to what, you could do this until you get to quadratic.
Yeah.
And then just do the quadratic.
Yeah, that's exactly what we're gonna do.
That's it.
We're gonna try to get stuff down to a quadratic and then we'll do quadratic methods.
That's.
Cause we have easy methods for quadratics.
That's it.
Alright, synthetic division is up. And so this is Christmas. Anyone still working on it?
So,
1 second, okay. Okay,
I just have a question, but I think you're right.
okay, let's see if I answer it. So this is, we got the -2 out front. I got 1, 3, 5, 6. Bring down the 1, -2 times 1 is -2. I add, I get 1. -2 times 1 is -2. I add and I get 3. -2 times 3 is -6. I add and get 0. This was an x cubed. So this goes down by 1x power, so we got 1x squared plus 1x plus 3 times x plus 2 equals that top.
and it's not factorable, so we do the quad formula.
Then we would do the quadratic formula, yeah.
Or
And we already know how to do that, so we're not gonna do that right now. Notice, we again have a remainder of 0. The remainder of 0 is required for a root. Or solution of the polynomial function.
And just by looking at some of the problems, I don't think we can use U substitution for some of them.
Why would we want to do U substitution?
Like, can we factor out like maybe the X or the.
Notice there's no way of grouping right here that we're gonna have a good, or we can do grouping to do a. Where the last problem, we could have done grouping here.
Yes.
I could have grouped, I take x squared out of here and a -9 out of these two.
Yep.
I could have done grouping, I can't do grouping here.
Or
So while we're on this. Is. Not if, is. X equals. -6, a solution. To x cubed plus 3x squared plus 5x plus 6.
by looking at it,
Don't look, okay, so. Just try it. So what you're gonna try to do is do the same synthetic division. Do synth division and look for a remainder of 0. I have no idea.
We end up with.
Randomly chose -6. I probably should have chose -1 and had a much easier one to do, but I didn't.
Well, I mean, so. Because if we could use this, well, theoretically, I could say that 1,273 is a factor of this problem. Like, and I can just use it as the x is the thing that equals x. And then factor from a random function into the same problem.
But if it doesn't have a remainder of 0, it doesn't divide evenly into it. It's not a factor.
So it's that would mean that it's not.
Yeah, a remainder that isn't equal to 0 means it's not a factor. So if I did this here. Oops. -138 plus 6 is -132. This says if I divide x cubed plus 3x squared plus 5x plus 6 divided by x plus 6, I'm going to get x squared minus 3x plus 23, oops, minus 132 over x plus 6. It does not divide evenly. I have a leftover or remainder. Let's say this is f of x. What is f of -6? Let's plug it in and see what it is. Someone do this on a calculator for me. Let's see, that's -216. This is 36 times 3 is 108. Minus 30 plus 6. This is -108, -138 plus 6, -132. I guess I beat the calculator. Does anyone see anything interesting there?
Yeah, you got the same remainder.
Look at that. If I stick in -6, I got -132 and I got -132. This is actually a theorem we're going to learn today. It's called the remainder theorem. The remainder theorem and the factor theorem go together. If you plug in a number and the remainder is 0, do the same thing and plug in -2. What is f of -2? -18 plus 6 is -12 plus 12 is 0. So there is a way that's technically even faster than synthetic division to see if a number is a root. Plug it in and see if you get 0.
Well, because it's claimed to be a solution, so is it a solution?
Yeah,
Yeah, it just, is it a solution?
well, this section is technically over in 3 minutes. But if you guys want to keep working, I will give you a harder one. And let you go crazy and impress the shit out of people walking in.
Two,
What?
oh, the other two roots are they negative two?
I don't know what they are. Did you go through and do it?
Yeah,
You did it that fucking quick.
yeah.
Well, then you're working faster than everybody else. You're just gonna have to wait a second for a while. Cause here using that, like knowing that the remainder will be zero doesn't help you. You kind of have to do the synthetic division to find the coefficients of it that keep going down. And if you're going that fast, you're gonna fucking do just fine in this area. Fuck, that's, I think, quicker than I could probably do it. Although if you just did f of -2 and
Oh, yes, yeah. we just-
if you took the,
Yes.
like, just guess the number, but don't do that.
All right, well, it's nice talking to you again. I'll see you around. I'll be gonna.
Got a remainder off of the root too.
Not root two, just, oh, the root equals two?
Yeah. the
Did I
root-
write it down wrong?
So fine. So the root equals two, or does that mean that's the first thing?
I'll do the first one.
That's not happening. Positive. Oh, yeah. Happy silly. Positive.
It's positive 14.
All right. I'll see you later.
Right.
Yeah. I think this is 4x plus 1 and x minus 2. I think it backwards.
Yeah, that would be it.
Let's see, 4x squared, negative 2x. Nope,
Because it's-
plus x, negative 8x is negative 7x, yeah.
Yeah.
But yeah, if you don't recognize the factors, the quadratic formula would still get you these same answers. So
So what happened there? Brought the 4 down 3 times?
I was doing each root and getting a lower polynomial each time.
Alright,
So -1 is -2 isn't the solution is -1, correct?
They're all solutions. That's that, if you plug in 2, you're gonna get a 0. You plug in 1, you're gonna get a 0. You plug in -1, you're gonna get a 0. It looks like if we plug in -1/4 or x equals 2 again. So we got x equals 2, x equals 1, x equals -1, x equals -1/4, or x equals 2 again. Shows up twice, doesn't it? Something we'll learn today, x equals 2 is a root with multiplicity of 2. How often does an answer repeat?
Yeah, I feel like this table might show up as statistics. I've seen it before. And I'm like, I feel like not in a math class.
Statistics is a math class.
It's kind of, well, I guess, yeah,
There's a shitload more math than anything else in that class.
that's true.
And there are classes that use statistic in them, but they are not statistics courses. And actual statistics course is always in the math department. At any school. I'm gonna hit stop record.